Hi, welcome back. Sorry about that. Like I said, we had a family coming out to visit, so I needed to stop and handle that for a little bit. That being said, I do plan on going a little late today. Today is the first day we're joining into the one button game jam, so I would like to spend a little bit of time getting caught up on, you know, make up for that gap because we are joining 3 days late. So picking up where we left off, we kind of landed on cards a roguelike simulation game where we are more or less performing a simplified version of game dev tycoon. We need to come up with a project name for it. I'm tempted to say we just go down the path of something short term, at least the one button game dev. Might want to look into this a little bit more, especially if we ever want to expand this past that. I'm not going to maintain that because we will be handling our to-do list through a different segment. Characters. I think in this situation, our characters are going to be very dynamic, to the point of like RNG. We'll probably have ranges per level boosts that are all randomized, and so if you get a level 1 versus a level 5, and so on and so forth. I need to fix something just real quick that I noticed earlier and I completely blanked on. Huh. Sorry about that. That should fix the issue that we were seeing on with Stream Elements. Okay, back to it. So I think we're at a state where I'm ready to move forward with our implementation. We do need to refine our cases a little bit more, I think, but at this point we're boarding into the point where we need it to be a living document. So let's run on that path. I plan on reusing the cat catch that we set up previously. We will of course need to rename it, but it does it does have everything that we need initially or initialized within it, which will give us a solid start point. And again, when I say initialized within it, here we're just talking. It's got the boilerplate in place. Okay, we need to find everywhere we use the phrase cat catch or cat catch. Uh, let's call it one button. button. That should solve that problem. So now if we run make clean and make build debug, build slash one button. All right, not ideal that we're getting an error when we try and launch that, but this is what I expected. Well, not I didn't expect an error. I did expect it to get renamed though, and that's what we were checking here. So we're good there. The Let's start off by fixing our TTF error. I'm willing to bet this is tied to importing a TTF. We're probably failing to import the font. We don't need those. We've got nothing under assets, which is probably going to be our main issue here. All right. Everything should be good on that front. For now, I'm going to, we will need font. Don't get me wrong. I imagine we're probably going to need this at some point in time. But that should be good. Make build debug and build one button. We are able to build. This should be displaying a window. We have a window. I guess it helps if we put literally anything in it. We don't have a renderer right now, so it's of course not going to be rendering anything. The solution we have for this is that we need to hook up how we're going to be handling our window, our game state. So we need our render frame implemented. If we provide it with this is the cleanup we're using here. I'm going to go ahead and just remove everything to deal with TTF. We'll keep it imported so we don't have to relink it later, but that's simple enough. We should be able to re-add back in initialization logic. So I want to decouple our event handler and our renderer so that we are dumping out a I think the idea here, what I'm struggling on is how I want to handle our decoupling, to be exact. So we have the situation where we should be rendering out a few different options. One of those being the main menu, one of those being the moment to moment is all a card selection. So game loop, which is going to be card selection. And then we have our summary slash score screen, which is the end of the game. So we've got main menu, core game loop, summary screen. Those are the main things. Within main menu, as we defined before, we do have settings that sits under here. And then within the game loop, it's going to be card selection. I'm calling them cards. I don't know if cards are the correct phrasing for it, to be honest. But that's what we're running with. So let me get our music going. The This should be pretty easy for us to render out. Um, and then we have our summary slash score screen, which would just loop us back. So we don't really have to worry too much about that. Let me expand this to there. My normal maximize shortcut key is not wanting to maximize. Sorry about that. So this gives us our high level for it. Does not handle our moment to moment, but this gives us a rough place to land. So in order to trigger a renderer here, we need to provide, I think, let's go back to our technical design. I think we forego on this because this is going to be another situation where each action directly results in a render. So we technically don't have to re-render until a change happens. Although we do have the weird side effect that no matter what it loops, I do want to add animation given time. So we should perform our render cycle every time. If we're performing the render cycle every time, I want to perform the interactions off the main thread if at all possible. But we can perform it within the logic off sync from our game loop if we need to. It dumbs our renderer down quite a bit. Renderer, if we do it on the main game loop, we do need to tie animation trigger updates to our game loop if we want to keep it on main thread. Technically, we don't need to, but I can't sleep our main thread, which is how I would handle our off-thread updates. Provide a main function that sleeps every 100 milliseconds for 100 milliseconds, and then calls a when it wakes, it calls a asynchronous task and then goes back to sleep. And then we can add within the task hook a blocker. And so if it is currently operating on a task, it just blocks, or maybe a debouncer, so it would it would just collate updates, use the latest. That's probably the best thing to do. No, because then we run the risk of what if we miss one of them? It would have to queue them, because if we miss one, it's gonna run things out of sync, which means that we're getting further and further, because queuing is going to become a problem if our operations start getting heavy. Us, if we assume that every single operation is heavy. If it's the occasional heavy operation, I guess it wouldn't matter as much, but let's do some cleanup. We don't need collision detection anymore. We do want to add basic animation given time. So we have technical, like required, and then we would have nice to have, so like a given time. So within each of these, we need a category for must have, a category for nice to have, and then a category for call them stretch goals. And so animation fits nicely into, I think, a stretch goal. This is no longer relevant to us. We have to have game menus, but it's also not a technical thing for us that fits into our screens. Virtual sizing, which is more or less done at this point. We have to have a web build. Web build through WebGL. Okay, so this gets our, we'll put that here. Animation can be a early pass after that. We need to lock in our theming. So the theme is built around game dev. We are doing, I think we need to upgrade this to 32-bit graphics. Now let's keep with 16-bit. Color palette, I think we need to go with a more bright, vibrant, like fun. Let's go with a bright, vibrant. We want whites and colors and stuff like that. We don't want to go with neutrals. So warm colors. Visual graphical theme. We are dealing with two primary categorizations of these. We have one categorization being the cards, and one categorization being the environment. I think we need to go for a, like, if we follow the game dev tycoon approach, then we would put it in a setting. And so we would show people working in the background kind of thing. I think that might be too much for us. In which case, we might want to drive this as a menu slash almost like inventory style, where things are laid out when we have the seats for each of our people. We might do one little headshot icon to show it's a person kind of thing. Very little in the way of visual customization as things change, more like numbers go up style. Uh, that would help reduce the amount of things we need to do from a graphical standpoint and also give us nice little, you know, if we get time to do characters with animations, we replace that with an animated character. Otherwise, we're relying mostly on drawing menus. Give me 1 second, I'll be back. And we're back. Alright, so I think that goes for our environment. I think the cards then overlay. We can expand this to have more graphics as time goes on. I think we're to start with, let's keep this as simple as we possibly can from every standpoint. Um, we define our game loop elsewhere as well as our gameplay mechanics. So this is more on technical requirements and our basic theme. Okay. Which means we're going to need so if we have a structure where we have menus, we have at the top level, we define a something like a screen manager. Its job is to toggle between screens. We then maintain a menu screen and a game screen and a score screen. That would give us the options here. And so on the menu screen, we have settings, we have main menu screen, we have a settings screen, and then no other. Yeah, there's no other screens, so we need a screen manager. which would be an inherited class that lets toggle between these. Then menu screen would define what each of these look like and provide the possible options to screen manager. So it gives it as a state machine essentially. Game screen, I think we do game screen as part of score screen, which would be our summary. Based on how we laid out our game flow. So our post-game summary, that would be one screen. We have our, for now let's just call it setup screen, and we have our play screen. So that would give us the segments that we need for our initial setup. We could do the requirements gathering, these as part of that. We would then have post-game summary. We need our play screen is the day-night iteration, where we loop back and forth between these, which means we need to handle so setup runs through these two. Requirements gathering is technically part of setup. So that we have a run start. So this is going to be the modifiers we define as part of setup. So set run modifiers. We then transition into so that's one screen. We then transition into a cycle setup. So we'll call this a new run screen. We then have a new cycle screen. We'll call this new game, new cycle, which lets us perform cycle setup, aka what game are you building? We then have requirements gathering. No, this one is, what are you building? This one is what are people looking for? Like these are your run modifiers. These are cycle modifiers. These are your, like, what are you building within the scope of that? Then we had our game, the play screen, which has the core game loop, which is going to iterate, and then we have the conclusion screen is end cycle screen, which has a cycle summary, and then we have the summary screen, which is the post game summary. Which we'll call end game screen, which is the game summary. That gives us all the screens we need to manage under game screen. So these are all of our states. These are the states for the menu. So that gives us the core screen management. Screen manager, we need to, so the screen manager will effectively handle the reused logic to toggle between screens in our state. The, or, and to trigger the correct functionality. Mostly this is defining functions and variables. So this might actually be able to function as an interface so that we can guarantee these two have the same um, reference points for when we're calling them in to toggle things. So these fit via inheritance under here. This defines the API for screens. We don't need to handle transitions. Technically, that could exist within here. We're not really going to handle transitions just yet, though. That might be something we want to tackle down the road, in which case we just expand this. So this handles our main menus and our gameplay loop as well as the summary. It does not handle the end. We need we then need some hooks from the game screen stuff into the if the intention is to keep a full separation of concerns so that we could theoretically eventually run our game state on a separate thread, then we really need a game manager, which would manage our game state. Our screen manager is already kind of doing this in the sense of transitioning between game states allocated by screen. We could go the opposite direction and say the game manager maintains the game state, and based on what game state we're in would determine which screen we're rendering. The screen manager could handle just the rendering side, screens to render out. So if this handles the render logic with a state machine based on those, then game manager can handle, yep, manages the overall game state. This would need to house, this would need to house, come on, this would need to house the um, triggers for card selection, which means we also then need to have, so the play screen is going to be, so we need to manage the deck, we'll call it. Then we would need to manage the yeah, we need to manage the cycles, which would effectively boil down to our current cycle, day night. How do we handle that? This would need to track all run details, which is going to be, anything from a modifier standpoint, all of our decks, cycle information, score, everything. So this is our run details. That's one thing that's going to have to be tracked in here. We would need to provide either provide the hooks to be able to trigger the mapping. I think it might be better to handle the mapping of current state. So if we handle a state machine within here, do we care? I don't think we actually care. We just expose ways to do all the things that we would do in our game. And then depending on what screen you're on would determine which of these can be called. And that way our renderer in our game logic get kind of blurry on this front, but all of it is call through actions. So when you click this button, it just calls the manager. And so if we have anything within the manager on what you can and can't do based on state, I kind of want to just transition everything into the game manager, and then the game manager just dumps out current state, and then this is just a dumb renderer. And so as the game manager state transitions, this renderer would just know what to display based on that, but all it does is call functions on the game manager to manage everything. The game manager could then contain all of the menu screen information as well. And it would have all of the state machine logic. And so this drastically simplifies the screen manager to where we only have uh, maps game state from game manager to the appropriate screen for rendering. And then we have just a series of screens. So, main menu would be a screen. We have settings menu, which would be a screen, and then we just need to maintain our state transitions. So if I dump these out down here, we have game states. So we have main menu, we have settings, new game. Okay. New game, new cycle, end cycle, end game. I like those. Play, I don't like. We could do day, cycle, night cycle. So main menu would be the main menu. We got settings menu, which is the settings menu. This allows you to set game modifier. We then can set cycle modifiers. We then have we need to provide methods to fetch options from deck. Method to select an option. We then have our day cycle and our night cycle, where day cycle is going to be make operational decisions, and then the night cycle would be see the outcomes. And then our end cycle is cycle summary, payouts, leveling, dot, dot, dot. And then our end game is game summary, which would include score, revenue, or stats. That's the word I'm looking for. Keep history details. Probably won't want to actually do anything with this just yet, but it would be nice to have. Actions taken, outcomes, da, 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 yes. Uh, do this gives us a pretty good layout. We've got a screen manager for rendering. We've got a game manager for managing our game state, for managing the game state. We have the list of game states, which are all of the different things, and this will be fed into a state machine that allows us to maintain and manage how we transition between the states. So that's all within our game manager, which means this becomes an enum. Maybe a little bit of logic. I'm probably going to implement this in enum, by the way, which means the game manager is the actual allocation on how we manage and transition through our states. It will have, we can push our actions and things that were drawn and stuff like that into a history that we just maintain in memory, and then if we wanted to, we could actually do something with it down the road. I don't think we will. Um, we need ways to interact with the deck. Yeah, I kind of like how this cleanly lays out. Which means we need to create this as an enum. We need to create the game manager and the screen manager and link them together. We, yeah, I think we want to create them separately and then connect them. That way, screen manager can run. Game manager would have the event handler. So connects to SDL event handler. The screen manager would just connect to the renderer and connects to renderer, SDL renderer, and game manager. This is just being fed information, which it then renders. It's a push style, which makes me want to. It kind of makes me want the game manager to house pushing stuff to the screen manager as changes happen. But the screen manager needs to know state information in order to perform rendering. So with this, the screen manager needs to know information about how to render. It kind of makes me want to run this as a subset of logic of the game manager, but once we combine these two, we lose the ability to run it on its own renderer. All of the rendering logic that would be within Screen Manager has to stay on the main thread, whereas the functional game logic can run on a separate thread. So I kind of want to keep those separate as best I can. We're just going to have to provide Game Manager to Screen Manager every time. Oh, we don't need Game Manager to perform updates here. We need Screen Manager to call in and fetch details from Game Manager. It doesn't provide any functionality. It doesn't trigger anything. All it does is say, give me your current state. And so it can get a read-only version of the state within Game Manager and then renders it. That way, Game Manager can just directly be connected to the event handler and perform all logical updates, transition everything it needs to. We would need to create timers if we want to do animation. So if we get to the point of animations, we have another class that needs to be created. I'm not going to put identifiers on these because these are non-repeated, so these technically would fit under the like factory style pattern. They're one-offs. Singletons. That's the word I'm looking for. I guess I could put singleton here. So these are singletons, which means there is exactly one instance of this ever within our program. And I guess we could even go so far as to create it in a way that it's self-instantiating and all references to creating them would just provide the reference to the instance. But I don't think we'll go that far. I think we'll leave it available to where you could technically instantiate multiple. We just don't. This is, let's put this mark down to get rid of some of the highlighting stuff that comes with it. Tech structure. We have our singleton here and singleton here, and then we have an enum here. And this finally will be a class. This class is our card. We need to maintain information about the texture. We need information about the, technically we want this to be a map of state texture, right? Textures, plural. So this is actually a vector texture. This would provide us with the card state. Let's give a enum here for card state. Card state identifies this is going to be our animation states. So idle or hover or active, selected, or moving, flip. So depending on what states we want to do for animation, that's what we get here. And so this is where we would handle our iteration for how we do animations. So if we are performing a render of our cards, we would want to showcase them within the screen. In say idle, we have flip, so we might want idle to be face down. Hover would trigger. When we start dealing with these, we want the position alignment. How do we handle animations is what this is coming down to. I have it from a conceptual standpoint that we can, if we have a vector of animations, we just need to know animation count and current time, and we can iterate through them. That's not the problem. And so we can transition at a frame rate and then current frame. That's easy. We don't have any problems there. The problem we run into here though is that when we're dealing with animation of cards, we position. Position is the thing we're struggling with. How we handle current position. So I think we need to also maintain position, which is our XY. I think we're going to need some additional information on here. Uh, First off, I think one of the things we're going to have to do here is instead of maintaining this, I think we might want to do SDL's recdef, and then position here would also be SDL recdef. And so we have a position that maintains where on screen. We have a map that points to what all do we need to know in order to draw our frames. So we need to maintain the texture, SDL texture, which would be a, what's the word I'm looking for, sprite map. So this would be our full sprite map. Then we can maintain our card state for each of our transitionary states, which I think we probably want to stick with something like idle and select for now. Oh. The frame rate determines the rate at which we rotate through our sprite map positions. So this needs to be a vector of sprite map positions. We can then iterate through this vector in a loop based on frame rate. We maintain the one we're currently looking at in our current frame. This gives us the basis for an animation. This renders it onto the screen. So this is now everything we need to handle a sprite of pretty much any kind. So let's abstract this out into sprite, and then we have a base sprite state. Let's call it sprite with state. Let's call it t. T. Uh, when we instantiate a sprite with a card state as our variable in here, we get idle and select, which means we populate idle and select with a vector of rect f's, which would render out everything. This now allows us to render. So we still need to figure out state machine. How do we transition between states? We need to figure out I think that might be it. Now that I think about it, we don't need to index much when it comes to selection or anything like that, because that's all really triggered through our um, game manager singleton via the event listener. We do need to know current selection, but this is where we handle that. So we don't actually need to transition our state machine here. We transition it here. Okay. Show options for cards. Transition between currently selected card. That would handle all that. That gives us everything we need to render out a sprite of any kind. We have the enum for maintaining our card state, which gives us everything we need for our game manager to handle state selection on the cards. What other state managements or sprite options do we have here? We have a handful of. We're going to have to render text because we're going to have to output numbers. So I think we need to create, because our sprites are animated, I think we need to create a secondary class for rendering out non-animated visual structures, which would include the menu pages and all those kinds of things. And it's going to embed text within itself. We need to render out, so we need object. This is going to need to know a texture. Right, give me just a minute. And I'm back. So I think we need to render out. These are going to be intention being static textures, which means it would still need to maintain position. So if we move this down here, do the proper object-oriented thing, and extend object of t. We don't actually need t anymore if we maintain it this way. That provides our texture, which could be either as a texture, or it could be yeah. So we're joining the one button game jam. So I've kind of been outlining it over here. This is our game flow. But from a concept standpoint, what I kind of landed on, I have so many screens open right now. Conceptually, what we landed on was a roguelike simulation game using a one button approach. So I'm kind of modeling a lot of the core around games like specifically Game Dev Tycoon. If you guys have ever played Game Dev Tycoon, it's the underlying principle behind Game Dev Tycoon, which is a game about making video games. The iteration loop is going to feel very similar on, are you making an RPG or whatnot. But I'm wanting to make it, instead of just a base simulation game, it's coming in as I want to be a roguelike. Which means that we're randomizing a lot of things, and so we're adding in a card draw system where instead of just I'm building an RPG, an MMORPG or whatever, you would get options based on what you have unlocked thus far on your iteration loop on your next game. You can then choose from among those options and iterate. And so the moment to moment would be like business day decisions that are made, which is when you come into what I'm referring to as the day-night cycle. So you would make a decision, and then you would see the repercussions or outcome of said decision. So you can get an immediate feedback loop. And this would be the main iteration cycle. Prior to that, we have what I'm referring to as a new cycle. Technically, this would be a new game you're developing, like a new product, um, where you choose modifiers. So we're building an RPG, for example. That's where this happens. And so this is the outermost loop. And so this is the core game loop. This would be the point we iterate over on repeat. This is the moment to moment, and then this is the more macro level of it. And then the new game, end game, is where you set your like round level modifiers. So think like I'm blanking on the game. I just looked this up earlier. Slay the Spire. Think Slay the Spire, where you have that like iteration style of it's a roguelike deck builder. And so in a way it's drawing some from that deck building approach, but for the most part it's more on the like choose a card to make it take an action, that style. Uh, yes and no. There will be some game level modifiers that are RNG, just like when Slay the Spire starts and you can get a choice to randomize things. I think I'm going to seed it to where you always get one guaranteed choice that will like reduce difficulty to help with difficulty curve stuff. But when it comes to the new cycle, it's going to be as the iteration goes on, you'll get more options, and I'm going to probably do a weighted RNG to push towards more late game complex options. Um, just because building a small game every single time and never going into the in game stuff is just going to get kind of boring. So I want it getting bad rolls on RNG on repeat would ruin the run. Essentially, not ruin the run from the sense of you could lose. You could, in theory, maintain it, but it would just ruin the fun of the run. So I probably will lean towards a weighted RNG system based on number of iterations you've gone through already to help make that feel a little bit better, given some time. The day-night cycle, the operational decisions will have a similar thing. So it'll most likely have they're in. You can't really see it in here. It's really in one of these screens I was fiddling around with the game flow. Um, I still need to flush out what we're going to do on the operational decisions. So in Game Dev Tycoon, you just make a selection and let it iterate. So it's kind of on that line of make a business decision and then idle. So it kind of fits somewhat into an idle game. I don't want to go on that route. I want every day to have a decision. And so you draw cards, and which means the iteration cycles are probably going to be a lot quicker on how to do a cycle. But I still need to figure out how I'm going to track progress and those kinds of things to make it visually compelling. The conclusion segment, we're going to have completion of your cycle, which will have payout information, leveling, those kinds of things, which will be like up for the duration of that run. Payout is going to be tied to a currency based on what you built and the current market segment. And you're going to have to use your funds to keep your firm alive, is kind of the idea behind it. But this is also where you can get the upgrades that would unlock to enable new options from a cycle standpoint. So what, like, can you make RPGs now or MMOs or whatever? Kind of, yeah. I don't want it to do full deck building. I want to add cards, but you shouldn't be able to remove cards. RNG should handle a lot of that behind the scenes, the weighted RNG system, and so it'll start downplaying them. But in the beginning, you're going to see a lot of repetition. And as you add more, it'll lean more towards your new cards that you're getting that come through the unlock system. That's kind of the core concept I'm going for. We have 6 days. So 6 days as of 12 minutes ago. So, and I'm not using a game engine. I'm doing all of this in C++ with SDL. So I don't know how much of this we're going to get through. I want to get it through to a prototype phase because I want to know if this is a fun and engaging mechanic. If it is, we'll move forward with it after the game jam. If not, then on to the next game jam without thinking about it, kind of thing. But that's kind of the core concept that we're going behind it. I'm not completely sold on game dev as the topic, but I do like the concept of having the almost deck builder, like roguelike style, combined with a simulation game. So that's what we're really iterating on here is a roguelike simulation game. Um, and then of course it's for the one button game jam. So you when you get your card selection, press spacebar, cycle to the next card, hold spacebar to select a card. That's the entire user interaction frame that I want to go for, which is really limiting a lot on what we can and can't do. Texture and position, we eventually want to expand this to a menu object. I'm not sold on this name. Which would extend object and give us text. I think we need a font reference in here too, if I remember correctly. So this will let us render out texture information because it's an object. We can then overlay text on top of it. We are going to need secondary text position. For where the text should fit within our texture. Nice. Yeah, I spent the last like 12 or 13 years focused on front-end web development. Um, I've been running my own company doing contract and consulting, but mostly just R&D and working on what I want for the past couple of years. But before that, I spent a little over 4 years at Amazon just building front-end stuff in HTML, CSS, JavaScript, TypeScript, stuff like that. Um, I actually have a game I built when I first got into game dev just in HTML, CSS, and JavaScript. Um, but I quickly expanded to Godot, and then I started running into constraints in Godot that didn't make sense to me, and so it kind of ruined my enjoyment of working on games. Running into that, oh, I need to rename our folder now that we're transitioned over to a different game. But it kind of ruined the fun for me on working on those kinds of things when I was fighting against the tool that was meant to make it easier for me. And I know a lot of it was probably a combination of just lack of information on my part and not doing things right, so experience. But when I start running into things that feel like I'm fighting against the system, it it just feels wrong to me. And so in this case, I'm just writing C++ code with SDL, which is what a lot of game engines use for their graphics interface. Um, I've never, I haven't done anything as complex, but at the same time, I've gone further than the point at which I found the first thing in Godot that felt like it was preventing me in some way. And I haven't had that feeling yet. It's always like it's not that I'm being prevented in any way. There a lack of support for enabling things, sure, but nothing's blocking my path aside from I just need more information, um, which is great, and that's something I enjoy doing. But I also very much enjoy just writing code. Um, I think this will get us rendering of objects. We do have the outlier situation. Nope, we don't have an outlier situation ever of clickable interface objects. Our sprites will handle some of that, but we don't have. We do. We have menu objects where the entire thing is in fact a button. Because our main menu, we want to be able to tap space to cycle through our menu options. So we now need idle versus selected. Um, we then have technically we don't have to render text on those. I do eventually want to introduce sliders, but that might be something we want to skip for now. To handle our like scaling of volume, we'll just keep it low by default. Um, yeah, if we just handle it as a sprite, utilizing our card state, so we just treat our menu buttons as cards, it is technically a subset. Because this is really just a text object is what it is. Yeah, I think that solves our problem. If we just treat menu buttons as our sprite, we embed the font or the text directly into the sprite's image when we render it out. We don't have to worry about any of that stuff, and then we can just alter it for idle and select states and cycle it on animation like we do our cards. And that would allow us to reuse our cycling structure as well, which is all managed by our game state anyway, so it's already within that for cycling. We just have to point at a different vector of objects. I like that. Let's do that. All right, so that gives us menu buttons, our card structure, and a way to render blocks of text to the screen with background images. I think we'll just, I'm probably going to need, technically we can do line wraps, and we could have embedded textures in our sprites. So instead of, for a complex menu object, we, instead of just having a square, instead of just having a square with, you know, some text in the center, we, oops, we could technically offset this, add a line wrap in our text that we're storing. This would, and then, you know, additional spacing, we can do all of this within our string, setting our position, and it would change the whole block's position. Then we could embed, you know, some image if we wanted an image. We can embed that directly into the texture we supply. So we could have embedded images with text, and then this comes in through here using line wraps and setting our font and position to render out text on our card. So we could do, even then technically if we wanted to, we could expand this structure to use our, what are we calling this? We got frame rate, current frame, and this is our animation map. Sure. We could introduce something like an animated text object, which just pulls the animation map. It would pull the entire sprite object. I wonder if we can do, I'm pretty sure we can do multi-inheritance in C++. Yeah, we can. Okay. I just want to make sure we can do multi-class inheritance. Oh, hell yeah. It's nice and easy in in C++ as well, too. So we could do multi-class inheritance to pull in both our sprite and our object, assuming that in our text object, assuming that we don't have to worry about collision on object space because they are pulling from the same. In theory, that should be fine. Because if we can pull sprite, we get our animation stuff. If we can pull text object, we get our text stuff, which would allow us to then animate a card and overlay text on top of it if we ever needed to get to that point. That only impacts us when we have dynamic text, which means that we could even do this as static and then some value below it that is dynamic that gets positioned if we wanted to. So that is all optional for us. I think that covers all of our GUI elements, as long as we don't have dynamic objects. Which if we do, we can technically use our sprite structure, provide a different state that is and we could do dynamic frames that don't have content within them. We can use the object to just render a texture. So this allows us to do static and dynamic screen elements, and then this allows us to include dynamic text. We can do static text within a block here, or dynamic element with static text, or dynamic text, or whatever we want to do here. We just can't programmatically change it, which is where this comes in, because it allows us to set our text through the code. I can't think of any other use cases that we're going to need, so I'm going to start building this. We should probably move this to here. Let's do here. No, I want below that. Let's do here. So that should give us a pretty good layout. I am going to need to undo the changes we made earlier and bring back in fonts. Which means I'm going to have to remember how, so this is done. I am going to have to remember how we are initializing fonts in location. I'll have to pull up some of my old code for that. Quit. The code for structuring our fonts was handled in location when we did the renderer, if I remember correctly. But connect 4. Game renderer. Nope. Let's try again. Game render.cpp. That's the one I want. Alright. So this is how we rendered out text. This was actually creation of positional data, texture from surface, color. This is providing the text itself. So render text, the importing of font. Here we go. We are going to need we defined what we wanted these to look like in our design. We now have Screen Manager and Game Manager. Screen Manager is our renderer. So new file, Screen Manager.cpp. This needs a Screen Manager.h file, which we are going to use to handle our imports. Actually, I think it's going to need all that, to be honest. We wanted to. I went to college for like over a decade ago. Is when I graduated, and while I was in college learning computer science fundamentals, my college taught everything in C++. I had a handful of elective courses I could take Java in. Granted, we were using C++ like 7 or something like that, and we're on like 23. We've had like 3 major versions of C++ released since then. So a lot of it was just getting in and writing code. But you also have to keep in mind, I have over a decade of experience writing web applications. So when it comes to coding, I'm quite familiar with what needs to be done from computer science fundamentals. So a lot of the C++ stuff is just learning what features have changed and figuring out syntax, just because I haven't used it in so long. But I used C typed or C based languages, so it's not like it's unfamiliar to me. It's just specifics, uh, which helps a lot in the learning process. But I effectively just dove into it. I did do a bit of when I was very first learning. I did a lot of coding utilizing like LeetCode. I've just jumped into a LeetCode problem, not because LeetCode is great for learning or that LeetCode is useful in most scenarios, um, but it does put you in a situation where you are exposed to things you might not otherwise see. And so it just gives me a point where I should be like, hey, I need to look into this. Or, you jump in there and it's referencing vector, and I just look at that and go, what the hell is a vector? And so it gives me just a point to jump off of in my research. Um, and then aside from that, I just find something I wanted to do and looked at example code for it or things like that. Um, I combine that a little bit with a tad of AI usage, so it's nice to have code completion through AI for a language that you're only partially familiar with, because then it's going to autofill things like this, and I'm gonna be like, oh right, I need this to be a pointer for based on how it's being passed, and this needs to be, a reference to text and not a standard object or a pointer or something. And so sometimes these kinds of things are useful. Sometimes it goes completely crazy, and I just spamming escape to get to stop doing things. But sometimes it's nice. So we want to trigger. What did I do here? Right, this was for creation of the path to our font, which means I also need to grab our font. Copy. Paste. All right. We needed it to import the font after opening the font and getting the path. So do this, and Screen Manager needs to have a constructor. Include Screen Manager H. I'm okay with that. Yeah, I think code completion is one of the most useful things that I coding related most useful things from AI that has been offered. I'm not a huge fan of a lot of the, especially agentic coding. Like I've tried, so documentation sucks. Like writing documentation, like it's not a particularly enjoyable experience. And so I've tried going full agentic on solutions and things like that. And what it really just turned into is I was the one doing all of the QA, writing unit tests and writing documentation and letting it do all the fun part of coding. And even then, it was still like wasn't actually doing it correctly 9 times out of 10. And when it did do it like visually correctly and like perform did the completed what it needed was being given, you would look at the code and it would just be hot garbage. Not that I'm going to be writing particularly great C++ code 2 weeks into relearning it, but some of the code things I was seeing coming out of it were straight up bad. Especially, because at the time I was trying to get it to write things in GD script and which I'd spent a few months learning, or like TypeScript, which I've spent years learning. So I can't imagine it's going to be particularly great when if I would let it go, or any better if I just let it go in C++. Although I have had better experience with the autocomplete tool on providing me things I want a little more consistently, which is nice. I do need to get a D structure in here as well. Actually, I don't want perfect. Not quite perfect, but close. Because you don't have textures. So I don't know why you were injecting that. I'm assuming it's just because I have this over here. Um, do I even store my font? I do store my font, which means I do need to check if font. Go. I need to hop in here to provide my class. Come on, come on. It is real nice to get rid of boilerplate. That's one of the autocomplete things that I love about AI is this was all boilerplate, technically defined over here already, and so just being able to tab autocomplete instead of having to copy paste and clear things out and stuff like that is real nice. Doesn't save much time, but it saves enough to make it worth keeping running in the background. We got Screen Manager. We got our renderer. We're storing our renderer. I actually want to swap these. This needs to go up and then hit include Screen Manager. That should fix that error. Alright, we now have our Screen Manager configured. It's simple, but it's there, which means we should be able to instantiate a Screen Manager. So let's do that. How do I want to handle this? We're already creating a new game state, which is a point of reference. I don't want to deal with this as a point of reference. I want to keep it as a concrete, which means screen. Oh, Screen Manager. I don't want you to be. Do I want you to be a pointer? Hmm. If I don't make it a pointer, I can actually set this as a Screen Manager. Right, I need a render upon instantiation. So yeah, let's do it as a pointer. And then I want to instantiate when we provide renderer, blah, blah, blah. When are we creating this new game state? Right, I provide a reference there, which means let's do Screen Manager. Game state Screen Manager, blah, 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 boom. To do initialize Game Manager. This should create our renderer initialization. We do need to trigger render frame, which is actually part of the Screen Manager. So let's ignore that for now. We don't need a load texture. Where did I put my render frame? Here we go. Let me just grab the let's call you SDL app result render frame. I really like render frame. I don't think we need to take anything, no. So I want to add in Is it here? Yeah, here. Screen manager, render frame, populate that, do your thing. There we go. And continue. Okay, so this should give us a blank screen. Okay. We're having that same problem we were having before. It's failing to initialize the font. It's weird though because we're actually attempting to initialize it now. Oh, right. I should probably go ahead and do that. Screen manager is a new screen manager. Oh, right. We need to, in the destructure, this needs a destructure. We need to delete. And then in our cleanup here, I'm gonna have to rename that. Nah, game state's fine. We call it game manager. Game state. No, I just want to delete. I should handle our cleanup. I really should be using unique pointers for my things though. That's not gonna fix my problem, but I need to figure out why our TTF code is failing to initialize. So let's step through it. I don't think we need to provide anything to it. I mean, let's just mirror what we did before. This shouldn't be causing a failure. It was. So, interesting. So this is supposed to be returning a Boolean. I'm guessing bool. I'm guessing it returns -1 instead of a Boolean. True on success or false on failure. Call SDL get error for more information. True on success, false on failure. It should be returning false. Interesting. Okay, so that's working, or at least it's not throwing an error anymore. We're passing in the renderer. We need to make sure we continue. Iterate should be calling game state render frame. I don't know what app state is in this context. I don't think I've ever used it though either. Nope. Should probably look at that. We got screen manager, render frame. So here we're calling game state render frame, which triggers this function, which is called screen manager render frame. Screen manager then calls render frame. Oh, right, there's one more thing we need to do in here. Where is my renderer? This. Now we should have a screen. There we go. All right, we're able to create a window and render to the screen. Let's close out some of these. Somewhere in here, I should probably do this. Init app state. I still don't know what app state is. All right. We need to handle events, which is going to be through our game manager. I want to. That might be something we handle on another stream. I don't want to dive too much into that. What I do want to get into though is if we pull back up this. Screen manager needs a reference to game manager, so I guess I could just create the structure for it. Game manager.cpp, game manager.h. Alright, and then in here we're gonna have a new class game manager, which is going to. You don't need the renderer. I do need everything else in that statement though. So game manager needs to take in nothing actually. Game state game manager equals new game manager. Again, you don't need that. We do need to also call game state renderer. Nope, game state screen manager. Set game manager, game manager. So in here, set. What if we do game manager? And then we can store renderer. Game manager, oh, I don't want it all. Then we need to store game manager, null pointer. We want to include game manager. if we do that, I could migrate screen manager's logic in here. That would remove our baseline constructor destructor logic to incorporate into here, which would be make that a little more readable. Especially since it's literally just allocation of stuff. If we do that, then in here, I can do, nope, 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 nope. I can do this, and we just provide game state game manager. We do need to add game manager here, which means we need to import game manager here. All right. Screen manager, what are you complaining about? Renderer, game manager. Fix that. Include game manager. We want to add I think I only need this, to be honest. At least for now. Nope, nope. I don't even think we need SDL on this one. Screen manager should handle all of our rendering logic. We are most likely going to need those at some point in time, which we actually don't need them here for now. So let's migrate these over here. Fixed our error in here. We now have our references tied together, and so in Game Manager, we can add a function definition for, what do we call it? Handle event. This is a header file. We don't want the full definition here. You're not returning anything. Oh, I do need SDL in there after all. This allows us to game manager, handle event, event, we return the value. All right, so now our main file is hooked up to provide high-level rendering, creation of the window, and then establishes and links up our game manager and screen manager. We then have just basic destructuring information down here. Nope. That should be within our deconstructor. All right, so this gives us destructuring, so we have our cleanup logic. So we now can create and delete. We can handle events and we can render frames. We've imported our image stuff. We've imported our TTF. Actually, we don't need to do anything in here for image. Established our window. I believe we've set up our... No, I need to set our... to do set virtual window size. Maintain aspect ratio. So we still need to go through and inject our virtualization for the window so that we can render 2D graphics in a set resolution on screen and let it scale up and do virtual and all that stuff on our behalf. There's like two or three just flags I need to set in SDL that I just can't remember off the top of my head, so I'm going to have to look that up. So we need to handle actual logic behind our render. We need to handle actual logic behind our event handler. We need to do instantiation. So this is where all the stuff we just documented a little bit ago comes into play. I need to go through and migrate these to the appropriate things. I also need to set up our enums. I might just incorporate this directly into our game manager, to be honest. Okay, I think everything's set up. It's about 5 o'clock. I am going to hop off for probably the evening. Most likely we'll pick this up and continue tomorrow. If I do end up doing a little bit more coding tonight, I'll probably do it off stream. Like I said, we've got 6 days to get this kind of handled. Um, Once we get into the actual core game logic, since we're dealing with SDL and not in C++ and not a game engine on the abstraction layer, we should be able to iterate through and get our core gameplay logically done quite quickly. Um, so we need to go through and handle all kinds of little things, but as it stands now, I think we're done for at least this stream. Tomorrow morning, around 10 a.m. local time for me, which is Central Time, which would be 11 a.m. East Coast or 8 a.m. Pacific Time. Yeah, 8 a.m. Then we'll hop back on stream. Again, we'll be running for about 6 hours is kind of the target goal on that, just on stream coding. I might try and handle a little bit of coding off stream as I mentioned, but yeah. So join me again tomorrow. We'll go through and try and get the basic screen rendering and try and knock out our menus tomorrow. I think will be the main goals for the day.